Hello everybody, today we'll discuss about the student Newman Keuls test using our studio. The student Newman Keuls test is a post-hoc test that is used to check a pairwise equality of means for several populations, and it is typically used after we reject the null hypothesis in the ANOVA procedure. And this test is similar to Taki's post-hoc test in the sense that both of the tests, that means the student Newman Keuls test as well as the Taki honest significance difference test, are used to check for pairwise equality of means. But there is difference. The difference of these two tests, that means the student Newman Keuls test as well as the Taki honest significance difference test, is that the student or this test is more powerful, meaning that it's much more likely to identify when the alternative hypothesis is true compared to the Taki's post-hoc test. And of course, this increases the probability that the student Newman Keuls test is incorrectly rejects the null hypothesis, even though H0 is true. And the assumption behind the student Newman Keuls test is that the parent populations follow the normal distribution, and also the variance of all the parent population are equal or homogeneity of variance. And thirdly, it is a sample variable chosen independently. I already imported my data, and my data name is RSVD trails. So for the rice crops, let's see the head. Yes, and we have fertilizer, variety, replication, and the response variable is the grain yield per hectare. So let's see our structure by typing str and in the parentheses write your data name. So let's see our structure. All the replication, the fertilizer, variety are characters, so this should be changed into factor using absolute factor function. So if you didn't, if you are not correcting or if you are not changing from numeric or character into factor, your ANOVA will be false. So type all the syntax using absolute factor, and the the variables that are going to change here is replication. So replication will be changed from the numeric into into factor. So type this. And in similar fashion, do for fertilizer as well as variety. So type this, run, and let's check back our structure. What's it look like? Yes, replication, fertilizer, and variety are converted to factor. So let's attach our data here, and you can assign any name that you want here. And here is analysis of variance, or you can also use the LM or linear model. Here's the response variable, that means the grain yield as affected by variety plus fertilizer plus replication. And again is a variety times replication. That means if you want to see their interaction effects. So type this and run. The reason why I'm here incorporated replication is random complete block design. So if it is already, you can skip this or you can omit rep from our script. So let's see ANOVA. Yes, here is a probability value for the variety, fertilizer, and as well as the variety and fertilizer interaction are highly significant. So you need to go, means a parachute technique, and among that one is the student Newman Keuls test. So in order to do that, the student or the snk.test is built on the agricole package. So you have to run agricole package by referring library agricole, type this one and submit to your studio. Then let's see, we will see three mean separation, one for the main effect of variety and fertilizer, as well as for the interaction of variety and fertilizer. So to do that, you have to indicate here is manna. What we created here is our model, and we want to check the variety, and means you can give the titles that you want. So I give result response of rice due to the variety effect. So you have to use this snk.test function, which is built in agriculture package. So type this one and submit your studio. Yes. So variety 2 is better than comparing to variety 3 and 1. Then back for fertilizer, for the main effect of fertilizer. So in similar fashion, change here variety into fertilizer, and yield of you can deal with fertilizer. You can also main is equals to null. You can omit if you don't want to deal with the title. As you see here, it's already displayed. It's already showed the yield of rice dealt with variety. So in order to more beautification, you can do that. And here is for fertilizer, you can do in similar fashion by changing variety here into fertilizer. Yes, again, here is fertilizer at the level of 150 kilogram per hectare is resulting highest yield around 5,679.63 kilogram of rice. Then lastly, let's see for the interaction. For the interaction, you have to indicate here is the response variable and variety times fertilizer, and also you have to indicate here is the degree of freedom, and here is the error minuscule. What you can get this from the ANOVA. Here is the value that you are going to type. Here is the degree of freedom for error is 33, and the minuscule is 5,132. So you have to copy and paste here. Then alpha, you have to indicate the level of significance that you are used. Here is alpha is 0.05, and you can also give the title for this. Type this and submit to your studio. So you will get this interaction effect. So the highest interaction is the highest grain yield of rice was obtained from varieties 2 and fertilizer at a level of 150 kilogram per hectare. So this is all about the student Newman Keuls test. If you have any questions regarding to my tutorial, you can address me through my email as well as YouTube comment box. Thank you for watching. Have a nice time.